chemical oxygen demand. So okay, this is one of the most important experiments in environmental engineering. So you will learn too much about this experiment or this concept in your theory class. So let's just start with the experiment with the principle. We'll just overlook the principle. Go through your procedures and read the principle ones. You know, any of the principles, if you are reading for the first time, you won't get. But by performing, you will come to know, and you will be more clear about the principle. So what does the principle say here? It says that any type of, like most of the organic matters can be oxidized by boiling a mixture of chromic and sulfuric acid. Okay. So here in this experiment, what we are doing? We are refluxing the sample that we have got with known excess amount of potassium dichromate in strong acidic medium. Okay. So what happens then? After refluxing it for some time, like 2 hours we need to reflux, then what happens in strong acidic medium? Okay, remember that. So what happens that most of the potassium dichromate is utilized, okay, or consumed, okay, and at the end of refluxing, like after 2 hours after the digestion, some amount of potassium dichromate will be unused, okay, like it won't be the remaining part of potassium dichromate we will be getting by titrating it against FS, that is ferrous ammonium sulfate, and by that we can calculate the amount of you can say we can measure the organic matter, oxygen equivalent of oxidizable organic matter. Okay, so let's start with the standardization. Okay, so here we are using ferrous ammonium sulfate. So very first step is to standardize it. So this is the flow chart, and this is like quite lengthy experiment. You need to add so many chemical reagents here. So I'm just giving you flow chart to make the process, the experiment simpler. Okay, so what do we need to do for standardization? For standardization of FS, first you will be taking 10 ml of distilled water. Okay, and in that you will add 5 ml of potassium dichromate, in which you will be adding 15 ml of H2SO4, and followed by ferroin indicator. After that you will start adding ferrous ammonium sulfate from the burette, and your endpoint till you will get the endpoint red brown. Okay, so this is quite complicated, but I have told you, right, that what happens, that ultimately what we are doing, I am telling you in simpler words. Okay, so what happens that the potassium dichromate, remaining potassium dichromate, we are what we are calculating, okay, like by titration we are measuring. So if more organic matter is present in that particular sample, then more potassium dichromate will be used, right, and less is the amount of organic matter, less potassium dichromate will be used. Okay, so what happens if we are directly taking, if you got some sample for COD analysis and you are directly taking that sample for the analysis, then what happens, the entire potassium dichromate gets utilized. Okay, and then how will we calculate then? So for that we need to dilute the sample. Okay, so here dilutions, we are taking dilutions, like if 3 ml of sample we are taking, then to make the volume to 10 ml we are adding 7 ml distilled water. If 5 ml sample we are using, 5 ml distributor to make it net. And likewise 8 ml of sample and 2 ml of distributor. Okay, so here is the flask. This is round bottom refluxing flask. So in this flask you need to first take a spatula of Hgso4, okay, mercuric sulfate. And why do we add this? For removing the interference of chlorides. Okay, what if chloride ions are present in that sample? What will happen then? See what we are doing. What is our intention? Our intention is find in simpler words. Okay, in simpler words I am telling you that what is our intention. We need to measure the amount of remaining potassium dichromate, right? But if chloride is present, then what will happen? Just think about this, that what will happen? It will be utilized, right? Tell me the reaction, which type of reaction will it be? Like what will get obviously redox, but what will get oxidized and what will get reduced? You need to think on this. Okay, so we will be so more potassium dichromate will be used, and that will obviously mislead our calculation. Okay, so for that we need to add HgSO4. One spatula will be sufficient. Then you need to add 10 ml sample. So sample as in like this. Okay, 3 ml sample, 7 ml distributor. This is sample 1 for example. Then like this. Okay, so for every dilution we need to make separate bottle. We need to make use separate flask. Okay, then so 5 ml K2Cl2O7 potassium dichromate we have taken, and sometimes sulfanic acid is used if you have doubt that nitrites are present in that sample that you have received. So in that case sulfanic acid is used. Okay, so then 15 ml H2SO4, strong acidic. See, now you will be clear about the principle. So 15 ml H2SO4 will be used, and you know this is taken as this volume 10 plus 5 should, like acid should be equal to this volume potassium dichromate and sample. So 15 ml concentrated H2SO4. Then you will be adding AgSO4 as a catalyst. Okay, so function of catalyst I won't be describing here, you know that. So after this you need to keep all these flasks like of all dilutions as well as blank. Okay, even here you need to perform blank. In blank what will you do? Instead of this sample, like here what we have done, sample plus distributor, but in blank total distributor will be there and 0 sample. Okay, so for such flasks or refluxing flasks we will have to prepare and keep for refluxing. Okay, so then it will be refluxed for 2 hours. After that we need to switch off that assembly and let it cool down and then do the titrations. I will explain it later. Okay, let's start with the experiment. Okay, so we are standardizing FAS, that is ferrous ammonium sulfate first. So for that we will take 10 ml of distilled water. In this we will add 5 ml of potassium dichromate. And 15 ml concentrated H2SO4. So while adding this concentrated H2SO4, you should be very careful. You should not pour it at like all at once. You should add it slowly and shake it. Now we will add heroin indicator. Two, 3 drops. Very tight. See, in this experiment you will see various colors. See, now this color. But we need reddish brown color, okay? See, now this color. So again we need to perform this thrice to get an average reading. Okay, so we are done with the standardization. Now we will be doing our dilutions. So see, this is blank. This is 3 ml sample, like 3 ml sample and 7 ml distilled water. This is 5 ml sample and 5 ml distilled water, and 8 ml sample and 2 ml distilled water. So in each and every flask, the first thing we need to do is addition of mercuric sulfate for removing the interference of chloride ions. After this, we will in first flask we need total. This is blank. Okay, so we need total 10 ml of distilled water. So first we will add the distilled waters. In second flask, 3 ml sample, that means 7 ml distilled water. Okay, so I am adding 7 ml distilled water. Then 5. So in third, 5 ml distilled water, and in last See, you can do it either ways. You first, like in the same measuring cylinder, this is known as measuring cylinder. So you can first add your sample, then make it up to 10 ml by adding distilled water, and then wash it with tap water, then with distilled water, and then make another dilution. So you can do it either ways. That is all on your convenience, like whatever you are comfortable with. Okay, so I have added distilled water first. I added 7 ml distilled water here, so that means 3 ml sample. This is 3 ml sample. Then in next 5 ml sample. Okay, so I am adding it from the same pipette. The reading was at 3, so I will keep adding up to 5. That means 8. This 8 ml sample. Then 5 ml potassium dichromate we need to add in a flask. After potassium dichromate, like 5 ml of potassium dichromate in each flask, we need to add 50 ml concentrated H2SO4. Remind the principle that I have told you, that we need to provide strong acidic medium. So for that, 15 ml H2SO4. So again, while adding this, you need to add this gradually, not at once. And each time you need to shake the flask properly. I don't know you people know this or not, but do you know the sequence of addition of, like, mixing acid and water? Should we add water in acid or acid in water? So you will search for this. Okay, and with reason. Okay, like if we are adding the acid in water, then why can't we add water in acid? This is COD reflux unit. Okay, see here, this is the hot plate and this is the reflux assembly. So what happens? We need to fix all these flasks here. So okay, then one of the pipes is attached to tap here, and what happens? All these things heat up and get condensed simultaneously. What is refluxing actually is? Refluxing is that term which is used for, or you can say that when boiling and condensation happens simultaneously, then it is known as refluxing. So what happens here? this all the solutions get heat up by using this hot plate, and there is one pipe with which the tap will be connected, and the water will be continuously running in these tubes, okay, in these glass tubes, okay. So when the vapors will form, those will be like simultaneously cooled down, okay. And yeah, so after this we need to reflux it for 2 hours, okay. And then after that, after 2 hours, before getting this things out, we need to pour distilled water from whichever tube you have attached to this. So you just need to add some distilled water. You know that won't affect, because what I have told you, unreduced, unconsumed potassium dichromate only we are interested in, right? And whatever potassium dichromate has to be consumed has consumed during this process, during refluxing. So even if we are adding distilled water, that won't affect, okay. So unfortunately this assembly is out of order, and we are unable to perform the refluxing. So I will just tell you the procedure. So okay, you have added the distilled water, then you need to get all the flasks out and add ferroin indicator to it. And while standardization, you saw the colors, right? You need to stop at the end point, which is reddish brown in color. Okay, what happens now? I told you, like earlier, I told you that we don't use the sample directly. What happens if you are using that sample directly, then that much amount is too much for that potassium, 5 ml potassium dichromate, okay. So what happens, that turns green, okay, here itself that turns green. So we need to discard it, okay. We are not going to take that flask in consideration. For example, this 8 ml for example, I am telling you, just consider that 8 ml one turned green while refluxing. So what you will do, you will just discard it, okay. You are not going to use it. Then you will be using just 5 and 3. Then you are in procedures, you have that formula for COD calculation, right? So blank's reading you will get by doing the titration, and this reading you will get for 3, and for 5 you will get. So what you will do, you will calculate separately COD of this 3 ml, then COD of 5 ml, and the COD of blank. You need to deduct that blank from the sample one, right? Okay, I will explain you that on board. Okay, one more thing. Now we are done with experiment. So one more thing, that in flowchart I told you to add AgSO4, right? Silver sulfate. I told to add it as a catalyst. But while adding in our flask, I haven't added. Why? Because first of all, that is extremely expensive chemical, okay. So we had avoided adding that because our sample was not that, like, it was just a lab prepared sample, glucose sample, so it does not need catalyst to start reaction, okay. But if you are receiving the sample from somewhere and you don't know about, then you should add that. We have avoided because we knew that the sample was lab made only, and that does not require any kind of catalyst to start reaction, okay. So okay, I have told you that in your reflux unit that if the sample turns green, then you discard it right there, okay. So in standardization, the reading we got, average burette reading, we will calculate the normality of Fs, okay, and you need to use this normality for the calculation of COD in this formula, in the given formula. So here, okay, tell me one thing, why this A is reading for what and B is reading for what? Okay, we are doing, we are actually calculating or estimating the amount of unreduced potassium dichromate. Okay, so in which like in distilled water it will be higher, or in sample it will be higher. Obviously, where there is more organic matter, more potassium dichromate will be used, and like less amount of it will be present when we titrate. So here blank will be more than the sample. Okay. So, and in chloride experiment, what was the case? Okay, you just go through your procedures and see by yourself. I am not going to discuss that here in this experiment. Whatever. So, you will just put the values here. Now, COD8 you have discussed. I am just giving taking this for an example. Okay, this is not necessary that always 8 will be discarded or it will turn green. Okay. So, just for example, consider that it turned green. Okay, and you discarded it. Okay. Then for 5, like for 5 ml dilution, you will put all these values and calculate. Here one more thing to be taken care of is ml of sample. Here you won't write 10. Okay, then there will be no use of using different dilutions. Okay. So sample you have used 5 ml only, and here 3 ml only. Okay. So this ml of sample, here for 3 ml you have used 3, and for 5 you have used 5. You will calculate these values, and finally the COD of your sample will be an average of all the dilutions that you have used. Okay, so 3, 5 and 8 divided by 3. So not necessarily always 8 will be discarded, okay, or turn green. So okay, this was all about this experiment. If you have any doubt or query, you can contact Rad Karma. Okay, bye bye, thank you.